Hello, everyone. My name is Joris Peels, and welcome to another episode of the 3D Printing News Unpeeled with 3dprint.com. So, if you haven't been here before, this is essentially it's a succinct as possible, fast as possible, efficient as possible for you news roundup, where we'll just give you the news you need for today, and we'll rank it from like the least impactful to the most impactful. And we hope that this will just be a really efficient way for you to start your day, essentially, to get an update about what's happening today. Now, most of the least impactful is always going to be a bit kind of imprecise, really, but we hope to get you things that are going to be sometimes obviously the most important stories of the day, and other times we're really going to highlight some things that maybe you guys have missed, just in case you've missed them. So we have 5 stories for you today. Again, this is a work in progress, so we're going to try and keep like 15 to 20 minutes, about 5 to 6 stories. But if you want more stories or more time or less time, totally reach out and let me know. So we have 5 stories for you today, and some of them are from 3dprint.com. Some of the other ones are from other sources. So we're going to start number 5. This one comes to us from Design Boom, and it's Wertel Oberfell make the auxetic shoe. So Wertel Oberfell, you may know from the Materialized MGX collection. They made the fractal table, of which I'm lucky enough to have one. Have now made an auxetic wear shoe. Auxetic is just a property where you have kind of strange or counterintuitive kind of like property. So something that when stretched, it doesn't come thinner in the middle, but it actually comes thicker, fatter in the middle. So what they've done is they've essentially made a bunch of 2D kind of sheets using material extrusion, FDM, and TPU, right? With shore hardness 98A. And these things, these two-dimensional shapes, they've used to make the shoe upper. So they haven't worked on the insole. They haven't worked on the sole, on which we've seen a lot of 3D printed work on already. But they've done the difficult part. Actually, I thought that the most obvious thing to do really was to use 3D knitting processes for the upper rather than to use 3D printing. So I think this is really exciting for that sense. The when force is applied to the structure, it binds across the structure. So the idea is that it will form itself to the foot and will be very, very comfortable. Now, the idea is also would be much more ergonomic than another thing. Now, for us, it means that we could actually make a 3D printed upper. So I think this is a really exciting project. It's a very practical project. Has a lot of practical implications. It's a new way of thinking about something in a completely different way. We're really literally making like 3D printed sheets essentially to use in a kind of normal shoemaking way with a shoe. So I think that's actually very exciting. I also think that material extrusion is the logical technology to be 3D printing shoes. With material extrusion, you can enclose spaces of air at specific locations. So you can make like custom air, not Nike air, but U air. And what we can also do is do variable density insoles, which is Gyrobot pioneered years ago. And that is that we make a variable density infill, but also we then change the infill pattern as we go up and down the shoe at every location. So at every voxel, we have a very unique shoe. So it's not just foreign to my foot, which is not, there's not that much that has value, but not a lot of value. But having a variable density insole at every voxel, a different hardness, that really can make a shoe just made for my walk or my step and stuff. So, but just generally, I do think this is a very exciting project and really nice to see designers really do some cutting edge stuff for once, rather than just be like, oh, it's a fractal and it's a hairbrush but made in a fractal. The fourth story is from 3D printing industry. It's actually from a couple of weeks ago, and I first didn't want to talk about it because I didn't think it was that important, but it's kind of been popping around my head, bouncing around my head since then. So I decided to bring it back. And it's called Rosswag Engineering makes a marketplace for LPBF process parameters. So Rosswag is a German engineering 3D printing service. They qualify materials and they can get materials to work for you and 3D printers. They've now made something called the AddiMap platform, which will let you buy and sell materials, data, and process parameter sets for LPBF 3D printing. And this is one of these ideas that it's like, I think it's so obvious that no one tried it, and it's brilliant. I think it's wonderful. I mean, a better profile could make it so that you could have a better build rate. You could build stuff faster, which will improve your machine utilization, let you make more money. You get better densities and better other properties. Also, think of like if you have to, if you change your material, or if you're going to change your material for a while or for or permanently, you're not going to be very good at that material, and you're going to have to qualify to get this thing to work, to get started. You're going to start from next to zero and a lot of parameters, a lot of different options, and you're going to have to put your production people and your production staff, on hold, not making any money with that machine while you qualify something, you're trying to get a material to work. So this is a brilliant idea, and I think actually they should have gone a lot further and do a lot of profile and parameter sets for FDM and other processes as well. That seem a little less critical, but there's also a market for them. I think this is a force multiplier for all of us, and I didn't get the attention it deserved. I felt myself bring it up again and again in conversations, and I was like, "Yeah, did you know about this?" And nobody kind of like thought enough about it, I think. So that's my number 4 story for today. Number 3 story comes from 3dprint.com, and that's about the EU funding a flax thermoplastic biocomposite. When I actually worked on a flax biocomposite using PLA years ago, I think I should have maybe done a little more with that. But essentially, what they've been trying to do is do a flax thermoplastic for marine use specifically. Now, this is part of the Interreg 2Cs program, and it's called Sea Biocomp, which has been spending about 4.2 million so far on this under the direction of Centex Bell, which is a Belgian textile kind of research company organization. They use SEAD or CEAD, which is a Dutch large format extrusion printer manufacturer, and also Polyproducts, which is a company like a 3D printing service for large scale items. And they've essentially come up with a couple of materials. One is a PLA composite, which they use for non-woven woven fabrics and compression molding. The other one is a flax reinforced PLA, and also there's a PMMA, which they can use in rift, compression molding, and additive manufacturing. What's nice about this is they're close to and in some instances perform better than conventional non-bio-based composites, according to the researchers. And sometimes the cycle times are faster, which in these no molding processes, of course, super important. Another thing is this kind of stuff is usually seen as like it's like cuddly, but where is it getting us? We have seen a lot of investment in materials by materials companies, but we have seen very little in terms of the increased sustainability. And I think this is like a flax is a much easier to recycle, much easier to take apart by a composite. The fact that they have to use PLA here and can't come up with something fundamentally different means they just don't have the money to do it. We all know that PLA has limitations and uses 7 liters of water per kilo of PLA, and it's difficult to compost and that kind of thing. So it's not ideal, but I do think this really staves the fact that we do need government research. No matter how libertarian or free thinker you are, or whatever in that area, we do need government research to really drive this kind of development. And I think this could be really interesting, really reusable material. That I think, and I love the idea that if you could say to consumers like it's corn and it's flax and it's a plastic and you're using it for your boat or you're part of your oil rig, I think that really resonate with people as well. The number 2, this news comes to us from Business Plus Ireland, and it's Stryker officially opens its 3D printing facility in Cork. So Stryker has been investing very heavily, like to the tune of hundreds of millions in 3D printing since, publicly 2016. They bought a number of companies, and they've really, really done a lot of work. They now have put what I could find. I think it was either I think it's some numbers say 200 million, others say 400 million. I think there's at least 200 million in this facility in Cork. And they hope to, it's 156,000 square feet, which is about 14,000 square meters. And it could bring 600 jobs to Ireland, which that's one of these things where you're not entirely sure how many jobs that actually means, right? So anyway, but Viju Menon, Group President of Global Quality and Operations at Stryker, said, with our experience in proprietary technology, we are excited to impact more patients and drive growth with this additional investment. We're also pleased to expand our talent base in Ireland with engaging roles across a range of disciplines. The Irish Prime Minister, or Taoiseach, which I hope I pronounced correctly, was there as well. He said that was a very welcome development for Cork and the Southwest region. Now, this thing, this Cork thing, is like it's a mythical facility, and it's already has been. It's the one place in additive I really, really want to visit more than any other. And and I really think that the future of additive is a lot of the future of additive is happening there. And I think what Stryker's done is to fundamentally invest in producing 3D printing parts, to working on the manufacturing, the quality, the repeatability, the reliability of this process to get these parts out the door. And I really think that that could be a huge, huge boon for them in the future. And I'm very, very excited about that. And I think that Stryker really will differentiate itself from the competition through its additive experience. Also, because its edge in additive will mean that it's cheaper for it to buy startups in 3D printing, orthopedic and other implant systems. And also to get a better understanding of which startups to buy, because which startups have really valuable IP. Um, so I really think that this is a really fundamentally interesting move for orthopedics, and this is going to be a really big driver of growth for us as well, the rest of us as well. So, what is the number one story? Now, the number one story is a bit of a Hail Mary kind of thing. And this comes to us from 3dgrenzlos.de, which is a German 3D printing blog, which I happened upon really quite coincidentally while looking for news for you guys. And I saw it like in one other place or something, but it's not been widely reported though. So it's a bit of a story. There's this company called Type 1 Energy, and they want to 3D print a stellarator. So they're based in Wisconsin. They're 3D printing a stellarator called the Starblazer 1. Now, stellarator is like a series of like magnetic, well, it's a donut shaped series of magnets, right? That together, kind of capture and control plasma, right? And the idea is that if you do this correctly, then you'll have a controlled energy or controlled fusion energy device. That, and that in turn would mean like low cost, nearly limitless energy. Now, so far, these guys have got some ARPA-E funding. There's nothing that I could find for today, at least, and I'm going to look a little bit more into this, but there's nothing I could find about more funding than this. There was no reported, like, I couldn't find much reported, like, investor funding or anything like that. So they have some ARPA-E funding, which kind of the energy department's DARPA kind of thing. And that is for additive manufacturing to be used for complex shapes to be built accurately, rapidly, and economically, and for high temperature superconducting magnets to reduce the size and weight of the reactor. Those are the two key things that they're going to make this Starblazer thing possible. The funding is like for 670 grand or something like that. Now, what the company now says is that the Type 1 is building a machine that builds a machine. The Type 1 is developing from the ground up Nebula, a proprietary large format selective high precision additive manufacturing platform made for the economical mass production of major fusion components. So we're seeing a startup that is saying we're going to build a 3D printer in order to enable our startup to have an advantage over competitors, similar to relatively space, which we talked about before. Now, they hope to achieve a 70% cost reduction in production costs and a 70% reduction in production time and a 40% weight saving. Now, these things are actually, have been proven multiple times that you can get significant weight, around a third generally is achievable. Weight savings and significant reduction in production costs and time for completely novel geometry. So that could be doable, right? They also hope to embed functional particles for thermal, neutron flux, and fatigue resistance. So apparently they will have to create some very special materials and structures to do what it needs to be done. That seems like very, very ambitious. And then they hope to make a 200 cubic meter build envelope. And that is insane. that is like so much more than anyone else is doing with any other area that it really kind of the scale of the ambition of the startup is crazy. Now, on the other hand, that does not automatically mean they can make it, right? I mean, it could be very difficult, but the idea that their interim step, right, is to build probably one of the largest, if not the largest, metal printing platform in the world, and that is able to process all sorts of exotic materials as well in a gigantic build envelope, bigger than a lot of houses. Is gonna that's gonna be really something to see. Now, again, this is a long shot. This is an incredibly long shot, but if they make it, the impact of these 3D printed tokamaks, which is a different kind of structure, or these stellarators, could be huge, of course, and the financial impact could be huge. Um, and so that's one thing. I mean, and so, but we don't know if these guys are going to make it. Of course, it's going to be really difficult for them. And I mean, I think we can all conclude that the 700 grand is not going to cut it at this point, right? So it's going to be very difficult for them to do this. Um, uh, but if ultimately they get the cash and they seem to be very bunch of very experienced people, and they can kind of get to go towards growth, um, their impact is going to be huge. But apart from that, we have to really be chasing these Oak Ridge guys, all these really cutting edge DARPA and ARPA projects, because their impact could be huge. Just the DARPA and ARPA are meant, or ARPA E, sorry, are meant to have a huge impact. And we are going to become like the one of the technologies that a lot of these guys are going to use to go to market. So that to me is very, very significant, right? To me, it's very, very to significant. And we also, what we're seeing is just similar to relatively space. That the printer, the rocket startup is making the printer the core of the startup. So we must realize that we're going to get companies that maybe are going to be competing with us at one point, right? Maybe Relativity is going to keep this technology proprietary forever, or maybe at one point they sell it or spin it out. So that is also going to be something we need to kind of figure out what to do with that. Do we really extra enthusiastically support Relativity's competitors, for example? These are the kind of things. All right, guys. So this is kind of what I wanted to talk about today. These are the 5 stories I found for you today. Again, let me know either privately or in the comments or something like that if you enjoyed this, if you hated it, if you want it to be longer or shorter, or if you wanted it to I don't know, be 10 items instead of 5 items or whatever, right? I'm going to put the links of these articles in the comments, and I'm also going to upload it to some YouTube, for example. And we're going to then find out some more things. So thank you so much for your time today. I hope you enjoyed it. I hope you found this very, very valuable. And come back tomorrow, because we're going to do this again. Thank you.